Okay, so in this video I'm going to have a look at the 2020 Higher Level Leaving Cert Maths Paper 2, question 7. So a company makes biodegradable paper cups in the shape of a right circular cone. Each cone has a radius of 3.3 centimeters and a slant height of 9 centimeters as shown. Show that the vertical height of the cup is 8.37 centimeters, correct 2 decimal places. So we're looking for this height here. This is our vertical height. Now, what we have in there really is just a right angle triangle. So we have this kind of thing here. So we have 9 centimeters up along here. We're looking for h, and we have 3.3 centimeters here, and this is our right angle. So what we can do here is just simply use Pythagoras Theorem to work out h. So we have h squared plus 3.3 squared is equal to 9 squared. That gives us h squared plus 10.89 is equal to 81. That gives us h squared is equal to 70.11. And that finally just gives us h equal to 8.37 centimeters. So that's the first part of A done. Let's have a look at part 2. Find a curved surface area of the cup correct to 2 decimal places. Okay, so the curved surface area is pi r L. So that's going to be pi times 3.3 times L, which is the slant height, which is 9. That gives us 93.31 centimeters. And that's to 2 decimal places. Okay, so that's part 2. Part 3. The diagram shows the net of a cup. Find in degrees the size of the angle theta. So we've got to find this angle here. What we have here is the radius of our net here. It's actually the slant height of our cup, but when it's folded out here to its net, you can see that it's actually the radius of what would be the circle around here. Okay, so the curved surface area. Now we have to find the theta here in degrees, so we're going to use the formula A is equal to pi r squared times theta divided by 360 degrees. So our area here is our curved surface area, which we found in the previous question to be 93.31. So that's equal to pi times, in this case our radius is 9, and our angle is what we've got to find, divided by 360. So this is just manipulating the formula. So what you would do here is just take our 93.31 divided by pi divided by 81, and whatever you get there, multiply it by 360. And you just simply end up with theta here is equal to 132 degrees. That's to the nearest degree. Okay, so that's part 3. Let's have a look at part B here. In order to avoid spillages, each cup is marked with a dotted line at F, which is 1 centimeter vertically below the top of the cup as shown. Find the volume of water in the cup when it is filled as far as the dotted line. Give your answer correct 1 decimal place. Okay, so we've got to find the volume of this section here. Okay, so the volume of a cone, is just going to be 1/3 pi r squared h. Okay, so we don't have the volume. We need to work that out. We have a third, we have pi, we don't have the radius, we do have the height. So there are two things in this formula we don't have. We need to find the volume. So we need to find, in order to find the volume, we need to find the radius. So let's have a look at the information we're given to see if we can work out what the radius is. Well, you can see here that we have this right angle triangle again, and within that right angle triangle we have another right angle triangle here. So we know that this is 3.3 centimeters from here to here. we know that it's 8.37 centimeters from here to here, and then it's 7.37 centimeters from here to here. We've got to work out what r is here. So what we've got here really are two similar triangles, so we can use the fact that sides are going to be in proportion here. So let's have a look at putting maybe 3.3 over r. So that's this side here of the big triangle divided by its corresponding side on the smaller triangle is going to be equal to 8.37, this side here, the big triangle, divided by this side here, its corresponding side in the smaller triangle. So it's going to be 8.37 divided by 7.37. So we can cross multiply here, so you get 8.37 r is equal to, we've got to multiply 3.3 by 7.37, that gives us 24.321, and finally then that just gives us our radius, which is 2.9057 34767 centimeters. Okay, so now we have everything we need for our volume equation here. So we're going to multiply 1/3 by pi by our radius, which is 2.9057. I'm just going to stop there because we only need our answer to one decimal place. So I've got 4 decimal places there, should be plenty. And then we've got to multiply that by our height, which is 7.37. When you do all of that, you get 65.2 centimeters, cubic centimeters there. That's to one decimal place. Okay, so that's it for part B. Let's have a look at part C. So in part C here, water flows into one of these cups through a cylindrical pipe of radius 0.8 centimeters at a flow rate of 2.5 centimeters per second. Find to the nearest second how long it would take to fill the cup to the line F. Okay, so we have a cylindrical pipe, which let's say will look something like this. I'm just going to take one part of this pipe. I'm going to take the part of the pipe that contains 2.5 centimeters. 2.5 centimeters. That represents 1 second of water that's going to flow into our cup. So we have a radius here of 0.8 centimeters. That's our radius there. So what I'm going to do is find the volume of water in here. So the volume of a cylinder is just pi r squared h. So we have pi multiplied by 0.8, which we've got a square, and then our height of our part of our cylinder is 2.5. Okay, so when you do that, you get 8 over 5 pi centimeters cubic centimeters. Okay, so we want to know then how long is it going to take the nearest second to fill the cup to the line F. So we want to know how long is it going to take to fill up as far as here. Now we already have this volume down here. We know that our volume is 65.2 centimeters cubic centimeters. So what I'm going to do is take our 65.2 divided by 8 over 5 pi, and that gives us 13 seconds. That's to the nearest second. And that's it for part C. Let's have a look at part D. So we have, let's see, the company decides to change the position of the line F, so it's going to change this line here in order to limit the capacity of the cup to 60 centimeters cubed. How far vertically below the rim of the cup should the line F be drawn? Give your answer in centimeters correct to 1 decimal place. Let's have a look at our new triangles here. So we have our right angle triangle again. We have a new height here. We know that this is 3.3 centimeters. and we know that this is 8.37 centimeters. We know we can say this is h here, and we can say that this is r along here, our new radius. So let's start. Let's look at our volume of our cone. The volume of a cone is 1/3 pi r squared h. We know that 60 is going to be equal to 1/3 times pi times r squared times h. Remember, we don't know what our radius is, we don't know what h is. So let's just multiply across by 3, so we get 3 6 180 is equal to pi r squared h. So we have two unknowns here in this equation here. So we can't work out r or h so far. So let's look at our similar triangles over here, see if we can make another equation. So I know that 3.3 divided by r is going to be the same as 8.37 divided by h. So in other words, this side of our large triangle divided by its corresponding side is equal to this side in the large triangle divided by its corresponding side. So now I have another equation with h and r in it, so I can do some kind of simultaneous equation here, some kind of substitution. So let's just multiply across here. We get 3.3h is equal to 8.37 r. That gives us, let's say, r here. We're going to work out what r is. So r is 3.3 h divided by 8.37. So what I'm going to do now is just substitute this in here instead of r and work out what h is. So let's work through that. So this means then that we have 180 is going to be equal to pi times, instead of r here I'm putting in 3.3h over 8.37. You have to square that and multiply by h. So all I've done is replaced this r here. Okay, so what I'm going to do here is maybe just multiply out this bracket first. Let's see, we have 180 on this side. We have pi. We can multiply, we can square our bracket here. So 3.3h squared is going to give me 10.89. h squared multiplied by h will give me h cubed. And then that's all divided by 8.37 squared, which is 70.0569. Okay, so let's just isolate our h. So what we get here is 180 multiplied by 70.0569, and then that's all going to be divided by pi times 10.89, and that will be our h cubed. Okay, so that will give us h cubed equal to, when you work all, this is all just calculator work, when you work all that out you get 368.5917994, and then finally just get the cube root of both sides. That gives you 7.16993572. So what we've done here is we found h, we found the new height from here to here. So what were we actually asked? We were asked to find how far vertically below the rim of the cup should the line F be drawn. So we actually have to find this part here. So what I'm going to do is take 8.37, subtract the answer that I just got, and that will give me this distance here. So let's work through that. So we have finally then 8.37, subtract 7.16993572. I don't really need all these decimal places, but that will just finally give me 1.2 centimeters, and that's to one decimal place. So in other words, the distance from here to here to one decimal place is 1.2 centimeters. Okay, that's it for this question.